friends, in this video we are going to study about the instrument spectrum analyzer. We will study that what is a spectrum analyzer, its block diagram, working and applications. So let us start with our topic. Spectrum analyzers are a type of signal analysis instruments which are used for the analysis of the electrical signals. Analysis of the signals means that we are finding the basic frequency properties of the signal. So spectrum analyzers, which are a type of signal analysis instrument, they are going to analyze the signal over the complete frequency spectrum of the signal. Okay, means over the complete frequency band, we are analyzing the frequency properties of the signal. So that are the spectrum analyzers. Also, in short, we can say that the spectrum analyzers are those analyzers which are doing the spectrum analysis of the signals. Spectrum analysis can be defined as So spectrum analysis is the study of the energy distribution across the frequency spectrum of a given electrical signal. Suppose that we are having an electrical signal. Okay, now it is the entire frequency spectrum, means in the range in which this signal is being defined, the spectrum of that signal. So the energy which is distributed across this frequency spectrum, that will be calculated in this spectrum analysis. Okay. Now, what's the need of doing this spectrum analysis? When we are studying this energy distribution gives us valuable information like about the bandwidth, about the effects of different types of modulation and the spurious signal generation, the noise generation in the signal. So this study, it gives us the information about all these things. So the spectrum analysis is giving us the information about all these factors. So if we are having the knowledge of all these quantities, it will be helpful in the design and testing of the radio frequency and the pulse circuitry. So in the radio frequency range, these spectrum analysis, it will be very helpful in the designing and testing of the electrical circuits. Now the spectrum analysis of a signal, it is divided into two categories. One is the audio frequency analysis and another is the radio frequency analysis. So audio frequency analysis, it is in the audio frequency range that is from 20 hertz to 20 kilohertz, whereas the radio frequency analysis, it is covering the range, frequency range 10 megahertz to 40 gigahertz. Now in the audio frequency analysis, this type of analysis can be done with the help of wave analyzers also. Like we are having the two wave analyzer, frequency selective and the heterodyne wave analyzer. So frequency selective wave analyzer, it also operates in the audio frequency range. So that analysis can be done with the help of wave analyzers. But the radio frequency analysis, it is of very much importance, and this type of higher range cannot be the higher range analysis cannot be done with the wave analyzer. So for that, the spectrum analyzers are used. Okay, and it is helpful because the radio frequency, it is used in a vast majority of applications, like in the communication, in the navigation, radars, wherever this radio frequency is having the applications. So the analysis in the radio frequency range, it is of very much importance in the electrical field. So spectrum analyzers, they are the instruments which are analyzing the instrument in the radio frequency range, and over the complete frequency spectrum, they are finding out the amplitude of the signal. So these analyzers, they are capable of graphically plotting the amplitude versus the frequency. So spectrum analyzers are capable of graphically plotting the amplitude as a function of frequency in the radio frequency spectrum. If we talk about its applications, so these spectrum analyzer, they have a wide range of applications in the measurement of attenuation, in the measurement of frequency modulated deviation, also in the measurement of frequency in pulse studies. So these are the applications where the spectrum analyzers are used. Now let us see the block diagram of a basic spectrum analyzer. So the basic spectrum analyzer, we have seen that the spectrum analyzer, they give us a plot of the amplitude versus the frequency in the complete frequency, radio frequency spectrum of the signal. So if we say that the spectrum analyzer, what is basically does, it gives us a plot of the amplitude versus the frequency over a portion of the radio frequency spectrum which is selected by us. So over a selected portion of the frequency spectrum, it is going to give us a plot of the amplitude versus the frequency. Now for this, the basic spectrum analyzer, it consists of a narrow band super heterodyne receiver. And a cathode ray oscilloscope. So a basic spectrum analyzer, it will consist of a narrow band super heterodyne receiver and a cathode ray oscilloscope. Now this receiver, it is an electronically tuned oscillator, okay, which is varying the frequency of this narrow band super heterodyne receiver. It is electronically tuned by varying the frequency of a local oscillator, and we are having the cathode ray oscilloscope. So on this oscilloscope we are having the x-axis display and the y-axis display. So x-axis display will be the sawtooth generator, okay, the internal sawtooth generator, and the y-axis output of the CRO cathode ray oscilloscope will be our RF input. Okay. So let's see the block diagram of this basic spectrum analyzer. So this is the block diagram of the basic spectrum analyzer, which consists of the super heterodyne receiver and a cathode ray oscilloscope. You can see the various blocks in it. We are having the radio frequency input, which is given to the mixer. Another input to the mixer is coming from a voltage tuned local oscillator. The output of this mixer is given to the IF amplifier, then the detector and video amplifier, which is connected to the vertical plates, that is the Y plates of the cathode ray oscilloscope. Now to the X deflection plates of the CRO, we are having the input coming from the Sawtooth generator. The output from this Sawtooth generator is also given to this voltage tuned oscillator. Okay, so these are the different circuits or different devices which are used in this spectrum analyzer. Let's see the working of the spectrum analyzer and the function of these blocks. So in this circuit, you can see that we are using a sawtooth generator. Now the sawtooth generator, its function is to generate a sawtooth wave. Sawtooth wave, it is generally a ramp voltage, okay, which is increasing with the time. So this is a ramp voltage, okay. We know that in the cathode ray oscilloscope we are always getting a plot of the signal, means we are displaying the waveform. The amplitude is plotted with respect to the time, but we know that in the spectrum analyzer we are plotting the amplitude versus the frequency. Okay, so here amplitude we will get on the y plates, and on the x plates we will get the frequency. So this sawtooth generator, it is going to generate the ramp signal which is given to the voltage tuned local oscillator. So the sawtooth generator is generating the ramp signal, and it is going to supply this ramp voltage to the frequency control element of the voltage tuned local oscillator. Now as this ramp voltage is given to the frequency control element of this local oscillator, so this local oscillator is going to sweep through its frequency band at a recurring linear rate, because ramp signal we know that it is increasing linearly with time. Okay, so it is going to sweep through its frequency band. Sweep means that it is going to repeat its waveform with the time. So it is going to sweep through its frequency band at a recurring linear rate. It is going to repeat its frequency. Now this sawtooth generator is also giving this sawtooth voltage to the horizontal plates of the CRO. Horizontal plates means X plates. So this completes the lower part of the block diagram. That in this lower part, the sawtooth generator, it is providing the sawtooth wave, the ramp voltage to the local oscillator also, and to the X plates or the horizontal plates of the CRO. Now coming here, this RF signal, the which we want to analyze, the RF input signal, it is applied to the input of the mixer here. So now this mixer is getting the RF input also and the input from the local oscillator. So to the mixer we are having one, the RF input, or we can say the RF signal to be tested, and another is the coming from the tuned local oscillator. Now this mixer is going to produce the intermediate frequency, which is the difference of these two frequencies. This is F1, this is F2. So it is going to produce the difference of two, which is F2 minus F1, which is known as the intermediate frequency. Okay. Now this frequency is given to the IF amplifier, which is going to amplify this. Now, as this tuned local oscillator, it is getting the input from the sawtooth generator. So, sawtooth generator is going to due to the ramp voltage, the local oscillator, it is going to sweep through its frequency band, and that frequency is provided to the mixer, so that mixer produce the intermediate frequency. Now this IF component is produced only when the corresponding component in this RF signal, only when the corresponding component is present in this RF signal. Okay, so only when that component is present, then this intermediate frequency will be produced. Okay, so one frequency is coming from local oscillator, one frequency is coming from the RF signal, and this frequency is produced only when the corresponding component is present in that. Now this is amplified and given to the detector and video amplifier, which is going to amplify the RF signals, and then they are detected and given to the vertical deflection plates of the CRO, giving us a display of the amplitude versus the frequency. Okay. So in this way, the spectrum analyzers, they give us the display of, or we can say a plot of the amplitude versus the frequency over the selected frequency spectrum. You can see that we have selected the frequency spectrum with the help of this tuned local oscillator. In whatever frequency range we want to use or frequency spectrum we want to use, we can change the frequency or control the frequency with the help of the local oscillator or by varying the amplitude of this ramp voltage. Now, if we see that we are getting on the CRO the display of the amplitude versus the frequency. Now on the CRO, generally we use the CRO to get a plot of amplitude versus the time. So that was the time domain analysis of the signal. Whereas here we are getting the amplitude versus the frequency plot. So it is called the frequency domain analysis of the signal. So in the time domain analysis of the signal, we are plotting the amplitude versus the time, and it is used for the measurement of the rise time, fall time, and the peak time of the signal. Whereas the frequency domain analysis, like the amplitude versus the frequency, it is used to measure the other characteristics, like if there is any deviation due to the if there is any attenuation, or if there is any deviation due to the modulation signals, so that can be measured with the help of the frequency domain analysis. So for the spectrum analyzers, they are used for the frequency domain measurements of the signal. So in this video, we studied about the spectrum analyzers. What is a spectrum analyzer? What are its uses? Then we saw the basic spectrum analyzer, its block diagram, and with the help of block diagram, we saw its working. So I hope that this topic is now clear to you. Thank you.